Cosmic Fury Unleashed, the enigma of solar storms. Our sun, a blazing sphere of plasma, is a celestial powerhouse. It bathes our planet in light and warmth, sustaining life as we know it. But the sun has a tempestuous side, capable of unleashing bursts of energy that can reach Earth with surprising ferocity. These events, known as solar storms, are a dramatic reminder of the raw power that lurks within our nearest star. Solar storms are not everyday occurrences. Like cosmic hurricanes, they erupt with a fury that belies their infrequency. Scientists estimate that these powerful events, capable of significant disruption to our technological civilization, occur approximately once per century. This means that within a human lifetime there's a chance, perhaps even a likelihood, of witnessing one of these celestial spectacles firsthand. But what exactly are solar storms? Imagine a sudden, violent outburst on the sun's surface, a colossal release of energy in the form of light, radiation, and charged particles. This eruption, often associated with sunspots and solar flares, can launch 1 billion tons of solar material into space at speeds exceeding 1,000,000 miles per hour. This phenomenon, known as a coronal mass ejection or CME, is the heart of a solar storm. As we delve deeper into the mysteries of solar storms, it becomes clear that these events are not mere celestial curiosities. They are potent forces of nature, capable of disrupting our satellites, communication systems, and even power grids. Understanding these storms, their frequency, and their potential impact is crucial for safeguarding our technological infrastructure and ensuring the smooth functioning of our modern world. Anatomy of a solar storm. When the sun rages, imagine a colossal explosion on the sun's surface, a sudden release of energy equivalent to billions of atomic bombs detonating simultaneously. This, in essence, is a solar flare, a sudden burst of intense brightness observed over the sun's surface. Solar flares are often associated with sunspots, cooler regions of the sun's photosphere marked by intense magnetic activity. These flares are just one manifestation of a solar storm. The real danger lies in the coronal mass ejections, or CMEs, that often accompany these flares. CMEs are massive eruptions of solar material consisting of plasma and magnetic fields that are launched into space at incredible speeds. These billion-ton clouds of charged particles can race towards Earth at speeds exceeding 1,000,000 miles per hour, carrying with them the potential for widespread disruption. The composition of a CME is fascinating. It's not simply a fiery storm of hot gas. Instead, it's a complex mix of charged particles, primarily protons and electrons, along with embedded magnetic fields. These magnetic fields are crucial, as they interact with Earth's own magnetic field, triggering a cascade of events that can have significant consequences for our planet. Understanding the anatomy of a solar storm, from the initial flare to the propagation of a CME, is essential for predicting their potential impact. By studying the sun's activity, scientists can monitor for signs of impending storms, providing crucial time for preparation and mitigation strategies. Earth under fire: the consequences of solar wrath. Earth, fortunately, is not defenseless against the sun's wrath. Our planet is enveloped in a protective magnetic field, a shield that deflects most of the sun's harmful radiation and charged particles. However, during a powerful solar storm, this shield can be overwhelmed. When a CME collides with Earth's magnetic field, it can trigger a geomagnetic storm. This interaction can disrupt our planet's magnetic field, creating spectacular auroras, the shimmering curtains of light often seen at high latitudes. While beautiful, these auroras are a visible reminder of the invisible forces at play. The consequences of a powerful solar storm can be far-reaching. Satellites orbiting high above Earth are vulnerable to the onslaught of charged particles. These particles can interfere with satellite electronics, disrupting communication systems, GPS navigation, and even weather forecasting. Furthermore, solar storms can induce powerful currents in electrical grids, potentially overloading transformers and causing widespread blackouts. In our increasingly interconnected world, where reliance on electricity is paramount, such blackouts can have devastating consequences, disrupting essential services, transportation, and communication networks. Shielding our world, preparing for the next solar tempest. The threat posed by solar storms is real, a cosmic reality check for our technologically dependent civilization. But amidst the potential chaos, there is hope. Scientists are constantly working to improve our understanding of these events, developing sophisticated models to predict their occurrence and potential impact. Early warning systems are crucial. By monitoring the sun's activity, space weather forecasters can provide alerts days in advance of a potential solar storm, giving satellite operators and power grid managers time to take preventative measures. Satellites can be placed in safe mode, and power grids can be adjusted to minimize the impact of geomagnetic disturbances. Furthermore, hardening our infrastructure against solar storms is essential. This includes designing satellites with radiation-resistant components and developing power grids with enhanced resilience to geomagnetic disturbances. Investing in research and development of new technologies to mitigate the effects of solar storms is crucial for safeguarding our technological future. As we venture further into the cosmos, both physically and technologically, our vulnerability to solar storms will only increase. But with careful planning, robust infrastructure, and a healthy respect for the awesome power of our sun, we can weather these cosmic storms and continue our exploration of the universe around us.